In section 2.4, we're analyzing graphs of quadratic functions. We have our quadratic equation in which we factored and we completed the square, quadratic formula, and square root principle to solve those. Well, now we're going to look at it in vertex form, which is this equation, and we're going to name our vertex, which is our HK, and our axis of symmetry, x equals h. And these are all the things we discussed in our transformations in 3.7, so pause it and write those down. Okay, we start our first problem. They give us this f of x equals x minus 1 squared minus 4. If I write our formula, our vertex formula above that, we can now name our vertex by our h and our k. Our h is going to be opposite this, so it's going to be, our vertex is going to be 1. And then k, our k is negative 4. So our vertex is 1, negative 4, which we can see it's right here on our graph as well. Axis of symmetry is always the equation x equals, and we use whatever our x value of our vertex is. So in this case, it's going to be 1. Our domain says how far to the left goes to negative infinity, and how far to the right, positive infinity. So our domain, negative infinity to positive infinity. Our range says how far does our graph from bottom to top. So the bottom is at negative 4, which is a bracket, negative 4, and the top of it, arrows on both ends, so it means it goes on to infinity. This is a minimum, and it's a minimum of negative 4 at the x value of 1. So when x is negative 1, the minimum occurs at negative 4. We're going to use this procedure to find the vertex when it's not in vertex form. This is vertex form, and when it's not in that form, like our example, then we need to convert it over, and we're going to use this formula. Once we get our answer for h, we're going to substitute it in here in red and solve for k. So the first thing we're going to do is we're going to name our a is negative 2, b is 24, and c is negative 64. Once we have those labeled, we pull our formula, and now we're going to plug in negative. Our b is 24, 2, and our a is negative 2, and we're going to simplify across, so that's negative 24 over negative 4, so our h is 6. Okay, now we go back into our original f of x, this equation right here, this portion, and we're going to plug 6 in everywhere x is at. So I'm going to have, for my k, I have negative 2. I'm just going to put a parenthesis right now as I go across. I'm putting parenthesis everywhere x is at from this equation right here. Now I'm going to substitute 6 in all those positions. So I have 6 and a 6. And then we're going to just simplify. So negative 2, 6 squared is 36. 24 times 6 is going to be 144. Minus 64. Negative 72 plus 144 minus 64. All of this is going to be 8. So k equals to 8. Our vertex is the order pair HK. So it's 6, 8. So that's how to find the vertex when this isn't in vertex form. Our last example, they ask us to find all this information, the vertex. This is not in vertex form, so first thing I need to do is name my A, B, and C. A is 1, B is 4, and C is 1. And then I'm going to write my formula for vertex form and solve it. So over to the left I have negative, and my B is 4. 2, and my a is 1, so I substitute that in and I have negative 4 over 2, which is negative 2. My h is negative 2, so I'm going to come put that as my first value in my vertex. And now I'm going to solve for my k. My k is equal to, everywhere there's an x in this, I put a parenthesis so that I can go back and substitute my h value and solve. So negative 2 squared is 4. This is going to be minus 8 plus 1, which is going to be negative 3. So my k value is negative 3 because this represents my hk. So that's my vertex. So now my axis of symmetry is always x equals whatever the x value of your vertex is. So that's negative 2. Um, and our concavity, if this thing, remember if our a value is positive, it's going to be pointing up. It's going to be concave up because this is positive x squared. My domain, let's stop and graph this real quick, and then it's easier to name our domain and range and the rest of this. So if I come over to my vertex, negative 2, negative 3, it's right here. And if I made an XY table to substitute some points in, I'm just going to do negative 1. If I was to plug negative 1 in everywhere x was at and solve, I would get negative 2. If I plugged negative 2 in, which is like we did here, our answer was negative 3. And if I picked an x value of negative 3 and substituted negative 3 in here and did the math, I would get negative 2. So I'm going to sketch all those ordered pairs up there and draw a rough sketch of my parabola. So concavity means it's pointing up. My domain is the left. It goes from negative infinity to positive infinity. So my domain goes from negative to positive. My range says from the bottom, which this is at negative 3, to the top, and it goes on forever in the top. So it's positive. It is a minimum. It's a minimum of negative 3 at the point x equals negative 2. So the interval increase says where is this thing increasing? So as I read left to right, it doesn't start increasing until here. So I need to describe my x value, which is going to be negative 2, and it keeps on going up till infinity. So that's going to be at negative 2 to positive infinity, because remember we're talking about our x values. And our decrease says where does this graph go down? Well, it goes down starting at negative infinity, and it keeps going down all the way until this point right here, which is x equals negative 2. So our interval of decrease is negative infinity to negative 2. So stop for a minute, go back over this graph, and look at how we get all of these values right here.